Thank you, Mr. Farooq, and especially thank COSMA and its members to give us an opportunity such as this just to talk from our side. And before I start, just a short brief introduction about myself. I am from India, but have been settled here in Germany for almost 12 years. I'm from Bangalore, and I will look after most of Asia Pacific countries, from Middle East to Australia, New Zealand, and Singapore, and these countries are surrounding them, and India. And yeah, especially I would be focusing much more in India right now. And yeah, this is a brief introduction about me. And so let us start with the presentation. Yeah. So the whole presentation is a general idea about UL standards and IEC 61439. It's just a brief introduction. Usually we have technical training or information sessions about these standards here locally in Germany at our office. And this goes about almost 3-4 days to at least a minimum of 2 days. And the whole information I have tried to squeeze it in almost 30 minutes, whatever is possible, and what would make sense for this time available. What I would suggest is once we finish this this kind of presentation, I'm open for questions, and if you are unable to answer these questions during this webinar, you can always get back to us through email, and we can briefly help out regarding the standards or any other queries. So let us start. Let's start with the UL standards. Maybe you have heard about UL standards in some of the switch gears or some other requirements. Maybe you were aware about the standards already. So just to give a brief idea, what is this UL standard? So what is this UL? UL stands for Underwriters Laboratory. This is kind of organization very similar to COSMA. It's in USA. And it's an independent organization, and it's a non-profit where their people have come together, and they have set up tests, and they have also set up standards, what is required in the electrical installation in US and Canada. So that's what the UL, the whole UL standard or the UL of company means. And UL as a company, it tests all the electrical devices and also the cabinets and electrical installations. And it has its own safety norms, and it has its own UL inspectors and UL laboratories. And that means if a electrical device has an UL specification or a switchgear has a UL specification, this literally means that it has been tested in an UL lab. So just to give an idea, there are around 1,000 standards in UL. It's not only particular to industry, from housing to very small electrical installation, electrical equipment, to very large airport installations, to very large electrical installation. There are standards set by UL. And this UL standard is applicable, as I said, only to USA and Canada. And this is not enforced by government. That means it's not a government rules or regulation. And in US, they would call it as a federal government. It's not enforced by federal government, but it's enforced by local states or local governments, or maybe the client who is making the setup, he would require this UL standards to be present. So now what is applicable to us as a panel builder UL? So the applicable standard would be UL 508A or 508. This is the standard which applies to panel builders or assembly of switchgears, especially for industrial control panels, industrial control panels. And how the standard is usually applied is there are panel builders who are already UL approved panel builders. So UL, a person from UL who would certify a panel builder, he would come and inspect the panel builder, what are his capabilities, and he would build up a UL file. And this UL file would contain all the information about this panel builder, what are his capacities and what he can do and what he cannot do. And once this has been done, then he's kind of certified UL panel builder. And whatever is panel building, he is able to put the UL logo on this panel, and also all the information about the panel as required by the standard on this UL. And this panel is ready to be installed in any of the United States or Canada electrical installation. For this information from our colleagues from US, what we know is that for this approval for a panel builder to be approved in UL is about 10,000, 15,000 US dollars. And this UL approved panel builder does not necessarily has to be present in US. So we know that there are panel builders in Europe, panel builders in Korea and other countries who are panel builders who are approved by UL, and that means that they are able to export or make installation in US. How it could be implied to us, or where it would make sense also for India, would be that if a machine installation is done in US, or if US is importing a machinery from Europe or from India or from any other countries, and it is and there is a local requirement by the law that it has to satisfy UL standards, then it is the responsibility of the machine builder or the machine supplier to make sure the entire system is UL proof. And that means there's going to be a local inspector who's going to visit and going to say, okay, this is according to UL and this has been built. So indirectly, if we're not directly selling to US, but we are selling it to some, exporting it to Europe or other machine manufacturers worldwide, and the final installation is in US. So that means that again, still the UL norms would be applied. And just to give a broad idea, if is UL norms, is it very similar to IEC standards? I would say definitely not. It's quite different, and the requirements are much more comparatively in certain area very stringent and tough. I think maybe this is due to how the construction or the housing is done in US. Maybe it's not as similar to Europe or other part or India or other parts of the world. So UL norms are much more strict and much more stringent in certain aspect. So that's about our UL standards. And from a Wohner side, we have expertise in UL. We have an office on manufacturing in USA, and we have a UL expertise team there. And if you are working with exports, and if anything comes up, then we'll be happy to help you technically to understand UL or to bring about your panel according to the UL standards. Coming down to IEC. So IEC 6149 is the new standards from comparative from before 60489, which has updated. Just to give a brief idea of what does it contain, IEC 61439. So it contains how the panel has been assembled and what are the conditions, and what are the minimum requirements, how the panel should maintain so that it works for safety reasons, that it works properly, and it's much more safe, which maybe in the construction we don't see that the accident may happen, but after installation, after long use, there is a possibility there could be hazards, and this could be avoided if we follow up the 6149. These norms or standards are not just raw information. It's actually tests or kind of research already made and noted down by an organization. So this is a relatively very useful information, and I would suggest that to get these standards and go through each standards and how it would make sense. Before I move through my presentation, I would just like to show you how the standard would look like. Yeah, so this is the IEC standard file, and this is, you can see, is licensed to us, and you can see it's a standard, and each and every possible details about what is the voltage and what is the requirement is written down in very, very specific details, and that means there is no room for interpretation, there is no room for discussion, everything is specified. Maybe if I go to so yeah, so here is
goes back.
Yeah, sorry. Yeah, here is an example what I wanted to show. This is kind of a table where which shows on rating of a bus bar, how much current carrying capacity is there for a bus bar can carry. I know in India we use general a multiplying factor, like if it's a copper, the cross section into 1.5 with the current rating or 1. So it's generally not according to IEC standard. IEC standard would say something like this. So what is the current rating here is an example, it's 20 ampere. And what would be the cross section if it's a solid bus bar or a standard bus bar? What would be the cross section minimum required and maximum it would allow? Also for flexible, what would be required? And here is an example that not only cross section, it depends on two things. One is the outside temperature or the temperature influence on the bus bar. Here you can see, and K would be the insulation material what is being used. So that would determine what would be the right cross-sectional area of bus bar to be used in IEC standard. Here it's clearly written down in the table. You just have to follow the table, and then it is according to standard. So that just to give an idea. So the IEC standards is much more very self-explanatory, and everything is written down much more clearly. Coming back to our presentation. Yeah, so here in IEC 649, what does it say? Who is responsible? What is responsible for a panel builder? For a panel builder. So for panel builder, he's responsible to verify the switchgear and the combination what he is using, that it meets the standards, the IEC standards. And also once he's making this combination or construction, this is according to standards, what is written down as I shown an example in IEC 16439 to 2 to 7, so that he follows each and every aspect written in this. And in case of any damage or any problem occurring after the installation, here would be the priority, how the IEC would say that who is responsible. So in the new standards, it would make the panel builder initially responsible for any kind of damage or hazards caused, and then would come original manufacturer, and third would be looked into the user. So that would be the priority. So that means the whole focus with the new standards is now focusing on panel builder and is quite installation, and not before it was much more on switchgear manufacturers and how it was constructed. Now it's much more on how it has combined and how it's working together. So that's a brief overview of IEC 61439 and what it contains. And once you have gone through the standards and you have built the panel according to what standard has written, so then you need to verify whether my panel, what I have built, is it according to the IEC 61439. So for this, the standard itself gives a procedures. It's called design verification or verification of your panel according to 61439. As you may already know, these are like two parts. One is the construction, how it has been constructed, and the second part is the performance. Regarding the constructions, and each and every, here you can see it's clearly mentioned what needs to be tested or what needs to be looked into, so that we can guarantee that 61439 as the panel has been constructed according to 61439. And if you take 10.2 example here, yeah, so each and every test what is required here, it can be solved in 3 ways. What it would, the standard would say that either you can guarantee that it meets the standard by actual testing, or by comparison with the design. That means you have already tested a panel which was already IEC 149 tested. Or third, by actual assessment. Assessment is just calculations, and you just assess physically whether it's matched. And here in this table, it clearly shows what test, what requirement can be assessed, that okay, it can be tested, or whether it can be, there is no need for test, we can just accept by comparison, or there is no need for test and comparison required, we can just only assess and say, okay, this is okay with it. So here is an example. If it's like thermal stability, you can satisfy these IEC 61439 standards either by testing or by simply assessing that according to the calculation whether this matches the 61439. So coming down to testing, comparison, assessment. So how do we test it? How do we compare, or how do we assess? This is again clearly described or written down in the standard itself. Here is an example. So here the first one is like resistance of corrosion. Here they clearly describes, if you mean by test, how the test should be carried out, and what should be the expected result. And if the expected result are there, then we can confirm that it's passed. If it's not there, then it is failed. So all the three, comparison of reference design, testing, and assessment, for each and every requirement, example like lifting of the panel what you have been made. So it can be only assessed only by testing, actually physically lifting the panel, and then it clearly describes in the test how do you lift the panel and how much height it has to be lifted, and what is the outcome of the test, what you look into. And if that test if results are achieved, then you say, okay, this is design is verified for this panel. And that does that mean that the new panel which has been built, whether it can be assessed only by looking or only by comparison, that you have made that panel lifting test in one panel, that means that the new panel what you have built is again already design verified, then the standard would say no, example like lifting. So if there is a yes, then clearly a procedure is written. So that also again means the standard is self-explanatory, and there's a lot of information on how a test is made and what is the result expected and how it's assessed. So everything is written down in this standard. Coming down to the group of standard tests, what we have seen, from strength of material to degree of protection of like IP enclosure and all these tests. Most of the difficult part, most of the things can be achieved by just following the tables and paragraphs what we see in standard. The difficult part comes in the performance test what we made, and this inside this performance there are two tests which are very difficult. What we have found that most of our partners find it difficult is the short circuit test and temperature rise test. The short circuit test is mostly difficult because switch gear, they have their own short circuit rating, but you are mixing up cables and wires and this short circuit tested switch gears, and this combination there's no guarantee that this would withstand the required short circuit requirement according to standard. So that's one of the difficult problems. And also temperature rise test, again, because you are using different kind of materials, you don't know what is the content of the material what you're using. So this also becomes very difficult in assessing or to just pass the test, assess that it would the panel would match the IEC requirement. So this we find are the two difficult parts with our experience. So before we move forward much more into details IEC, just want to give you a brief idea about Wohner. So the Wohner was established in 1929 in Rodenthal. We are located in Bavaria, southern part of Germany, and this is established in 1929. And we have production units in 4 parts of the world. That's in Germany, in China, and US, and Brazil. Most of the product which we are exported out is only from Germany, and other countries what we are manufacturing, it's for their own consumption. Here you can see this is the manufacturing bay in Germany, and most of our production is automated, especially in Germany. We have also R&D centers located in wherever production sites are, from Germany, China, and US, and Brazil. And here you can see this is our office in China. Just to give an overview of what is our sales and how big is our company, or we are kind of medium-sized company. It's still family-owned. The third generation of the family is running around the business. In 2019, we had a consolidated sales of around 117 million euros. In Indian rupees, it's around 1,046 crores, 1,000 crores plus. I think this is the revenue what we had in 2019. Total, we are around 773 people around the world, and we are present in around 19 locations with our own subsidiaries right now in India. So to get a brief idea of what does Wohner provide, or what is our bus, what we call it as a bus bar system. Traditionally, as we know that we have R by B, the bus bars running on top of the cabinets, and to attach the switchgear, we usually drill holes in the bus bars with nut. We put nut and bolt, and we are powering up the switchgear in this way. This we call it as a traditional system. And what we do with Wohner is instead of drilling and putting nut and bolt, we directly mount switchgear onto the bus bar. And how we do this is that we have adapters we can directly mount onto the bus bar. And this kind of a click-in solution. That means there is no mechanical work or mechanical drilling is required, and it's much more kind of a Lego system what you have for the electrical installation. Just to give an idea about our bus bar system presence, this was introduced to the world by us in 1980, 81, 82, and then it slowly developed into the market. Unfortunately, this system is very well known in Germany and also in Europe, but relatively not well known in outside Europe, what we could say. And that means that if you are importing some machines or some installations from Europe, then if you open up the cabinets, then maybe you have seen these installations. Little bit more details about the bus bar system. Not only just if you are connecting cables or kind of bus bars, what we call it, we have a clamps called, example, it's kind of spider clamp, where instead of drilling and connecting the bus bar to bus bar, you just put two bus bar, remove the installations, maybe it's flexible, and you just clamp onto the bus bar, and you tighten the torque which is mentioned on the clamp, and then that's it. So we call it as also a maintenance-free installation, and all these clamps are spring-loaded. That means that even with time, there is no need for maintenance, because it's going to expand and contract according to how the bus bar is expanding, contracting. And this would also remove any need for tightening of maintenance and tightening of screws and nut and bolts, because you are not using it. And also, since you are not drilling the bus bar, the short circuit value and also the current carrying capacity of the bus bar, it won't change, and it would keep it as simple as it is. So clamps is one of our solutions. From small cables, here you can see from 1.5, and we have really up to big bus bars to be attached directly to the bus bars. And for MCB and contactor combination, we have what we call as an adapter, where you mount the MCB and contactor onto adapter, and you mount this adapter directly onto the bus bar. That means like you just click this unit onto the bus bar. This we have from small 16 ampere single pole MCB adapter up to 1250 MCCB big adapter. So it's a different range according to the power rating it's available. So another advantage what we have with the adapter is we call it as a crosslink technology. Is that this adapter can have two parts. One, you can dismount the front part with the live current behind. That means that if you have maybe a lighting panel with 80 lights and 80 MCBs, if there is any problem with the panel or any problem with the installation, you don't have to switch off the entire panel. Just switch off the required MCB, and then you can dismount the front part with the contactor and with the live current behind that without any switching off the entire panel. So this could be an additional advantage for any process lines. Maybe you don't have to shut off the processors, and you can keep other process running and just repair or work on the adapters or on the exact problem where it's there. And this also has a micro switch possibility, where you can also pre-program what is the situation of the adapter, and to monitor whether it's on or off, or whether it's on working mode. So this is kind of an additional advantage what it brings in with the solution. So just to summarize, we are reducing the size of the panel from different heights, and all the installation is installed inside a height of 200 millimeters. And the bus bar system by itself is already conferring to Form 2, and you can build the system from 1 to 5 poles. And I think right now the 3 important points what is relevant for us is that we have made already the design verification for IEC 61439 for all the bus bar connections what we made. That means that we have already pre-tested the short circuit rating, and also we have pre-tested the temperature rise test. So just getting into much more in details, the short circuit testing or the short circuit testing is required according to IEC 61439. To understand briefly what happens during a short circuit. So I have a short video already played it. So these are 3 bus bars here running, and here you can see when there is a short circuit, there is this kind of electrodynamic loading on the switch gears and the bus bars running. That means there is mechanical vibration which goes on, and with high current, there's possibility that even the parts of the bus bar melts down, and you can see it, this energy release, so it flies off from the bus bar. So this is what physically happening during a short circuit current being passed into a cabinet. So yeah, I have some test videos also right now. So these are kind of tests, I would say, which have failed the IEC 6149 tests. Here are some of the video. Just to observe what happens during a short circuit test. You can see with very short period of time, there's a lot of energy release, and flying of energy is like melted copper. There's another test. Yeah. So again, according to IEC, this would have failed the IEC test. So here you can see with the short fluid down motion, there's a lot of energy released in very millimeter seconds. Yeah. So that's short circuit, and to make sure that your panel is not catching fire due to short circuit, or then that means that the panel is passing the IEC 649 standard. This is what is allowed. So short circuit withstand strength. You can guarantee that your panel would withstand strength. It's only by testing. Here you can see it's yes. That means you have to make the test, and then once the test is made, then the proof is done. Then you cannot reuse this panel. So it's only a test, and this can be used just for reference. So that is comparison is allowed. See, the comparison is allowed for short circuit. That means if you have already short circuit tested one of your panel, the same reference design can be used. That if you are building one more panel with the same reference, then you can refer to the already tested panel, and then your panel is satisfying the standards. So what do you mean by a reference? You can see the IEC has, this is again a table from the standard. Here's a list of questions, like 1, 2, 3, 4, 1 to 10. Once you are making a comparison or a reference design test, so you have to answer each and every question. And if one comes no, that means that your panel is not satisfying the standard. If all are coming yes, that means you are satisfying the standard. Yeah. So what does this question contain is usually it's always referring back to whether the example, the bus bar size what you're using in your new panel, whether is it matching the reference design panel, what you have made short circuit test, whether is it same or much more bigger. If yes, then you can have to click yes, and then you have passed. Then you just have to follow through this questions, and then once everything is yes, then you are assessed that okay, this my panel is IEC 61439 short circuit ready. And you can also be sure that in any possible way, if there is a short circuit, your panel is not going to catch fire or we have any hazards effects surrounding it. So in order to help you to build or achieve the standard, what we have done is we have already pre-tested the bus bar and its combination for short circuit values. That means, example, here is an example. IPH is kind of a testing lab. Maybe in India, it's like CPRI India, and its IPH is similar to that. And what we have made is we have made various combination of bus bar and bus bar holders. And we have made the test. Here is a photo from the test. Here you can see this is after test, how it would look. What we have done is we have taken the worst case for a bus bar. That means here we have no MCBs or fuse holders to protect during the test. So that we have made the test without any protection. It's one of the worst case possible. And also we have made enclosure inside this cabinet and for this bus bars. And we have tested this possibility for all possible worst case scenarios. And we have the reports ready with the short circuit value, how much it can withstand, and how this would help. I think this is example. This is a question from the table, what I showed you earlier, like the table where you make the reference design test. This is kind of second question here. You can see are the cross-sectional dimension of bus bar and circuit connection, each circuit of tested switchgear greater than or equal to the reference design. The reference design is, you can refer now if you're using Wohner solution as the reference design. And what we have done is we have made different sizes. Here is the bus bar sizes: 12 into 10, 12 into 5, 30 into 10, 30 into 5, 20. We have made a combination of many bus bar sizes, and we have pre-tested with different clearances from bus bar support. This is distance between two bus bars, and this is this short circuit value what we have achieved. This is the results from the test, and this table can be used for you so that you maintain the same distance between two bus bars, and you can guarantee that the system what you're building can withstand such short circuit current. Here, just to read example, if you're taking 30 into 10 bus bar, and if you are taking two bus bar supports and with a distance of 200 millimeter, and that means the system what you have built can withstand up to 70 kA. So this is what you get from the table. This is our table, but behind this table stands a report like this, and this report can be provided by us. And with this report, you'll be able to answer the reference design question here and click yes, yes, yes. And then your panel is short circuit ready or tested according to IEC 61439 and ready to go. This is one way how Wohner can help you in achieving this standard. And I think the another test what I informed is temperature rise test. So this is one of the difficult parts, where here is one more example of a table from the standard temperature rise. And here it mentions what are the different parts inside the cabinet and how much temperature differences. Here in IEC, they call it as Kelvin. It's not actual Kelvin, it's the temperature difference, what it's allowed compared to ambient. That means if you have a metal part inside your cabinet, maybe it could be a screw or it could be nut and bolt, then what it allows is only 15 degrees. That means if the ambient temperature is 30, the nut and bolt should not be above 30 plus 15, that is like 45-degree temperature. It should not go above 45 degrees. Or here example is terminal for extended insulated. If there is connecting terminals, if you're making a joint of cable to a bus bar, and according to IEC standard, the allowed temperature rise is 70 degrees. That means if your ambient temperature is 30 degrees, then the connection joint should not go above 100 degrees according to IEC standard. So this is a table given by IEC standard which needs to be followed. And yeah, if you're coming down to the temperature rise test, what is allowed and how in IEC standard, and how we can guarantee that your panel is according to IEC standard. Here, all the three is allowed. That means you can do the test and then, okay, it's allowed. Or you have already made the test and you can refer the test, that is also allowed. Assessment is also allowed. Assessment means the IC standard has set of calculations, and you just have to calculate with the information from your panel. And once you put in this information and calculate yourself, and then you have a value and you have following this value. And once somebody is assessing it, it just checks if calculation is right, and this is allowed. But that again comes down to calculating each and every connections and each and every parts what you are using, and also be sure that what you are checking for the material is what your supplier claims it is to be. So there is some kind of complications when you are taking the assessments. Mostly the testing and comparison is normally used in standard. So what we have also done for this temperature rise test is with the same lab here, you can see we have made a combination. We have made the temperature rise test already for you. Already we have done it for you. That means we have made, these are the clamps and cable joint with flexible bus bar with direct bus bars. And this is the load attached. This is the report, screenshot from the report. And here are the temperature measurements, what we have done it already. And that means that there are different ambient temperatures and different current passed, and how much there was a temperature rise in each joints, whether and if the temperature rise was it satisfying according to the IEC requirement. So here is an example. So the whole setup was for 1260 ampere, and example, the cable connection was copper, and allowed according to IEC 16439 was 70 degrees. The ambient was 29.9, they measured 67. So the delta was around 37. So allowed was 70 and we have achieved 37.6. That means it satisfies the standard without any problem. That's kind of overview. That means that you can use the same, if you're using our clamp and the combination of any flexible bus bars or cables with the clamp, that means you already have the temperature rise test made, and you can use our test what we have made as a reference, and then you can guarantee that this is how much maximum temperature the connection joint would reach, and this would also satisfy as per the requirement, the verification required. So not only the temperature rise and short circuit, here you can see we have already done other performance tests like dielectric properties, mechanical operations, clearance and creeping. I think this, at least the last three are performance tests. So these are IEC tests, and we have already pre-done all these tests, and this can be used by you. Once you're just using the clamp, that means you're already satisfying all the standards, and it is backed by the certificate and tests from us. And this can be used to build a really quality panel and to satisfy any client requirement that your panel is according to IEC standard. Okay, that's a brief view about our panels. Here are some of the application examples of our bus bar system build. This is, I think, a sorting plant. That is means this is exactly a kind of potato sorting process plant, where you can see the bus bar system being used, and you can see the entire bus bar system where it's empty, it's been enclosed. So it provides an IP20 protection for the entire system. And here with this particular example, the whole panel was rated up to 630 ampere, and it was a drive panel, and we were able to reduce the entire cabinet almost 30%, and the time also we were able to reduce for around 30%. So totally from 5 cabinets, we were able to reduce down to 3 cabinets. So that's kind of a size saving what you would get with the Wohner bus bar system, I would say. Here is an example from Bangalore. This is Coca-Cola plant in Bangalore, and this is their bottling and shrink wrapping machines. And here inside, once you open the cabinets here, you can see Coca-Cola has a collaboration with and partnership with Siemens. So all their machines and most of their machines are using Siemens switchgears. Here you can see, and our system is much more not brand specific, so you will be able to use any multiple brands. And here, especially in this plant, they were using Siemens switchgears. And here you can see this is a bus bar system, Siemens MCCB and other MCBs, and these are fuse holders directly mounted onto the bus bar, and especially for this large process and machines, and this only consumes very small space for the entire panel. And all the other things why Coca-Cola would decide with our solution would be that it's safe. Even after you can see removing the panel, there are no terminals which are exposed, and you don't need to put any other covers, additional transparent covers or such, and it's much more safe. And you don't have any access also if you want to physically access the power, and it's very easy to maintain. So as I said, there is no nut and bolt, and it's much more click in, click out solution. If anything is damaged, just switch off the panel and just click out the system and click in back the entire thing. So it's much more faster and easier. And mainly, as you can see, it reduces the size with all the switchgear combination, and it's compatible here with Siemens, but it's also compatible with all other major switchgear manufacturers. Here's an example for wind turbines. We are partnered with Goldwind wind turbines from China, and they also produce 1.5 to 2 megawatt of power distribution of wind turbines. And for their low voltage power distribution, here you can see a system. They're using fuse switch disconnectors by us, and the entire system low voltage distribution is from us. This is an example for wind turbine. This is an example for a CNC machine. This CNC machine is called Taurus, is one of the really big size CNC machines, and it is manufactured in Kubo, very near to us. And yeah, you can see for the entire machine, this is the cabinet where we are squeezed in machine motor controls and MCBs, everything into a small, very small panel. And this is one of our newest applications what we have with the CNC machines. So we are also in a large power distribution. This is our football stadium in Munich. It's Allianz Arena, and the whole football stadium is powered up with our power distribution here in Germany. We also make customized solutions for big projects. So here is an example. So Queen Mary is a cruise ship. I think it goes between UK and US, and the entire electrical system is made by us. And there were a lot of specific requirements and customization required, and we were open to work on this. And the entire electrical system is using bus bar system, and it's using Wohner bus bar system. Yeah, one of our newest clients or newest application is for supercharging stations for Tesla. The power distribution is from 1000 to 50 ampere, and each charging station is around 400 ampere. And here you can see they are using our bus bar system, where the incomer is around 1050. This was a joint collaboration with E10, and here you can see it's all E10 switchgear with special adapters only for E10. And then the power distribution is for high current. So this is one of our newest application examples. So just to summarize how Wohner can help you in achieving the standards. One is that the connection joints or the clamps or the bus bar holder, we have already pre-tested all the standard requirements, what the IEC require. And that means that there is no necessary for you to make additional tests and you to invest in this test. And we can just follow up, use our clamps and use our bus bar supports, and we'll provide the reports for you. And not only reports, this is according to the standard. We have foreseen what the IEC would allow for a reference design. So that means we are satisfying this reference design requirement. That means that you don't have to make your own test, which is going to be expensive for us. And if you're making your own short circuit test in a lab, it's going to be very expensive. This would avoid that. And regarding adapters, what I mean by adapters is we have special adapters for MCBs or MCCBs. If you want to mount a Siemens MCB or a Schneider or a Eaton, we have already made various combination of different switchgear manufacturers with this adapter. That means we already made a short circuit test for this particular switchgear with this connection joints. So that means that already your panel is short circuit tested with this switchgear manufacturer. You don't have to make again a particular brand related short circuit protection. Just have to use our adapter where we have made this adapter switchgear combination test, and this would be helpful for you. And in our website, we have a IE documentation software. That means that it's kind of a checklist. You just have to put your complete details, and you have to just answer the questions in this checklist. Once you end this answers, then you can take an output of the file. So this you can use as a documentation for your particular panel, stating that how your panel satisfies the IEC standards. So this software is available free for everyone to use, and this can be used by you right now to make your panel ready for IEC standards. Regarding UL, as I said, we have a team in India and also in US, and we have expertise in UL. If you are thinking about exporting to US and Canada, we are here to help you out in achieving the standards, and could be interesting market for, especially if it's export. Either directly if you are exporting to US, or indirectly if you are exporting to Middle East or Europe, and which goes anyway, final installation is US, then you have to convert to UL standards. So we'll be able to help you in that way. And as we have seen that we guarantee highest quality and safety. In the end, there is also save a lot of saving of labor time and effort, and also the size. So that is an additional plus in the end, which would bring with busbar system and usage. So there was a short survey made regarding the image, especially in Germany, how the Wohner solution is viewed. So here you can see the Wohner was viewed as better than the competitors.